So we already did the multiply and divide. Now we're going to do the add and subtract. Okay. Again, this idea of the word rational. Okay. That means, what do I have? What am I dealing with? Well, basically, I'm dealing with algebraic fractions. Okay. Another word for it, a rational expression would be an algebraic fraction. I mean, I could call it that way because I got that polynomial curve on the top. I got that polynomial curve on the bottom. So definitely I have a fraction going on. So again, back to when you dealt with fractions in middle school, you've got to be able to add and subtract them. Whenever you add or subtract, you have to have common denominators. Okay, so let's write that down. To add / subtract. I am going to abbreviate here, rational functions. You must have common denominators. And of course, when you first start, first few problems in My Math Lab, they're going to already have common denominators. All right, so then when they already have the common denominators, sometimes you can do them because they're so easy. You're just combining like terms on the numerators. You don't even have to show a lot of work because you can just kind of add them and do in your head. All right. However, when it's subtraction, sometimes because you got to go through and change the sign, it's better to show more work. So if I had something like an x squared plus a 2x minus a 2, and that was all over an x squared plus a 3x minus a 10, and then I wanted to add to that a 5x plus a 12, and then an x squared plus a 3x minus a 10. All right, so we can look at those denominators. I already have matching denominators. So then I don't have to worry about trying to get denominators. So this is no more than going through the numerators and adding like terms. Okay, so I will be going through the numerators, adding like terms. So adding like terms in the numerator. And like I said, normally when it's an add, I don't take the time to rewrite again because it just takes up more space. I can real clearly look at that and go, okay, I got an x squared. All right. Then I go through and I can go, there's 5x and there's 2x. So that's going to be 7x. All right. And then I can go through and I can, as long as I don't drop any negatives, I can see that's a -2 plus a 12. That's going to give me a +10. All right. So when it's add, I would say no need to do an extra step. All right. And then same denominator remains. They're already alike. I want a like denominator in my answer. So I've got an x squared plus a 3x minus a 10. Okay, now, unfortunately, you cannot assume that you are done at that point because what do we do with trinomials? We factor them. Okay, so you do have to check just to make sure and try to factor the top, factor the bottom, and see if anything happens. Okay, so that arrow is going to look like I meant add right there, and I don't like the way that's going to look. Let's fix that. My whiteout's not working the way I want it. I just don't like the way that looks. Ooh, there we go. Okay, since I'm going across here. Okay, so let's factor. All right, leading coefficient of 1, so that makes it nice. Okay, same thing on the bottom. Leading coefficient of 1, that's going to make it nice. Okay, so it looks like add across the board. 5 times 2 is 10. And that's going to give me the 7 in the middle. So that factored pretty easy. Okay, I need unlike signs. So again, 5 and 2 again, right? 5 times 2 is 10. I need a +3, so puts the positive right there. Puts the negative here to get the -10. Okay, and we were lucky. Something does factor. And by coincidence, the x plus 5 is on top of the x plus 5. It wouldn't have to be. You know, the x plus 5 could be over here. If I would have wrote it, x plus 5, x plus 2, they would have been on the angle. Okay, it doesn't matter as long as one's in the top, one is in the bottom. And then now we're down to an x plus a 2 and an x minus 2. Okay, so straightforward when it's add. All right, there's nothing tricky to it. Almost every time. Probably almost every time you are going to, once you get to this step, you are going to have to factor and something is going to cross out. Because again, just like when we were doing the multiply and divide, you start with a great big long problem, but your answers are going to be relatively small. Okay, so if you get something big, then you know you probably need to keep going. All right, and of course the paper's sticking together. Okay. Let's go ahead and do just one more add. I mean, I don't know how many of the easy ones we need to do. Let's do like an x squared over an x squared minus a 25. Let's go ahead and add to that a 25 minus a 10x all over the x squared minus 25. All right, so I'm adding. I've got a common denominator, so I don't have to do any work or anything. Now, just, this is worth saying this. I have had people try to start crossing out first for whatever reason. Okay, so obviously this is a don't do this, but a lot of time I see people take this type of expression and then they go, oh, look, there's an x squared up there and there's an x squared down here. And so they just cross those puppies out. Okay, you can't do that because this is a no-no. So don't do this. All right, because this is a binomial. This is together. So I can't take this and cross it out with something in the top. I can't take this number and cross it out with something in the top. But this I see a lot. And then because they cross it out, then they go, oh, well, I crossed it out. I'll just put a 1 up there in the top. I mean, so I just saw that and I'm like, oh, people do that all the time. All right, so we got to not do that. Okay, so I don't need to show an extra step because it's add. I have no like terms in that numerator, but what I am going to do is I'm going to choose to write this as a trinomial. I'm going to put my x squared term first, then my x term, then the 25, so it looks like a nice little trinomial that I can factor. So I'm going to choose x squared, then a minus 10x, then a plus 25. All right, just looking ahead, knowing that, oh, hey, that's going to form a trinomial, and it's going to be easier for me to factor if I do that. All right, again, leading coefficient of 1, so this is nice. And instead of going across, I'm going to go down because it really doesn't matter what I do here. All right, so I need an x and an x. 5 times 5 is 25. It's going to give me a 10. All right, let's see. And then minus and minus would give me a positive 25 and a negative 10 in the middle. And then hopefully we recognize that denominator as being the difference of two squares. So an x plus a 5 and an x minus a 5. All right, which ultimately allows us to cross those out. Okay, so again, like I think I said this on Monday, you cannot stop here. Like you can't give me an answer that's got stuff crossed out. You have to rewrite it again so that we can clearly see what's being crossed out, what your final answer is. Okay, but again, very small, simple answer there. Okay. Okay. How about if we let you do one on your own? Same thing, then we'll do a subtraction one. Oh, we want to beat a dead horse here, but x squared minus 2x all over an x, wait, let's make that an x squared plus a 3x plus an x squared plus an x, and then an x squared plus a 3x. Okay, so I'll stop talking for a minute and let you do that. Okay, hopefully this one kind of went kind of smooth. All right, we got an x squared term here, x squared here, term here, so I can add those. All right, so I'll have a 2x squared. All right, then I had a negative 2x and a plus x there. So when I add those, I'm going to have a minus x. All right, so a pretty simple numerator. And then an x squared plus a 3x on the bottom. All right, I'm going to go ahead and go across on this one because it's nice and short. Only thing I can do factor-wise here is to factor out an x on both the top and the bottom. So I take out the x, it's going to give me a 2x, and then a minus 1. X divided by x gives me the 1. Take out the x on the bottom here. It'll leave me with an x, and then just a 3. All right, that lets the two x's cross out then. And we're down to a 2x minus 1 all over the x plus 3. And again, pretty simple compared to what it was. All right, so these are not hard. Okay, the adding and subtracting is not hard. All right, now on the subtract, I will do an extra step. Okay, as opposed to like doing this in my head, I will probably add an extra step on the subtraction because you've got to go through and change all the signs. Okay, so let's suppose we had an example, let's throw some more letters in the normal. Let's put like a 3y to the third minus a 5x to the third all over an x squared minus a y squared, and then minus a 4y to the third minus a 6x to the third, and then an x squared minus a y squared. So again, still common denominators. All right, now the reason that I do put in an extra step on this is because, again, anything to the right of a minus sign, I have to subtract everything. So really, this is a quantity, so this forces me to go through and change those signs, okay? Because in essence, it's a plus minus 1 if you were taught that way, but it goes through and changes the sign. Sometimes you can see it easier when we write it all as an entire numerator all the way across. So if I write 3y to the third minus a 5x to the third minus, go ahead and put that set of parentheses in, 4y to the third minus 6x to the third. All right, then you can hopefully see why we have to go through and change all those signs. And people just have a tendency to miss it, trying to do it from here straight down to the next step. All right, so then I would probably write 3y to the third minus 5x to the third, distributing in the negative, minus 4y to the third. Negative times negative makes it a positive 6x to the third. And yes, it makes for more steps. However, okay, it just keeps you from dropping negatives. All right, now I'm going to go through and combine some like terms. So these two things are like terms, and these two things are like terms. All right, so from there, I'm going to have, and again, it depends on how much looking ahead can you do. If you do no looking ahead or no thinking ahead whatsoever, you may do these two first, and that's going to give you a negative y to the third. All right, and it's in front. That's kind of tacky. All right, and then put these two together. That gives me a positive x to the third, and then all over that x squared minus y squared. All right, well, sitting like that doesn't really make sense. All right, it is going to make more sense if I choose to put the x to the third first and then go minus a y to the third. It prevents having a negative leading coefficient. All right, because you don't want to factor out -1 and then start messing with that. It just kind of like makes the problems a whole lot worse. All right, clearly we can see the bottom is a difference of two squares. That numerator, perfect cube, and a minus. So this is the difference of two cubes. So in other words, this is our SOAP formula, if you remember the acronym SOAP from the last chapter. All right, so that's actually right. Difference of two cubes. Okay, so formula. Ooh, it's been a while since we've done that, right? Okay, so the cube root of the first one is x. Keep the same sign, minus, that's the S in SOAP. Cube root of the y, which is y. Okay, then we take the first term we have here and square it, so x squared. I'm ready for the opposite sign, so it becomes a plus. All right, then I take the a and the b and multiply them, so x times y gives me an xy, and then always positive for my last part of the acronym there, always positive, and then I square the last term. Okay, so doing that difference of two cubes, it's been a while. Okay, so difference of two squares is just an x plus a y, and then an x minus a y, which then lets us cross out the x minus y's. All right, now this is a trinomial that possibly could be factored, so you do have to check. All right, I'm going to come up here just for a lack of place to write it. So as of right now, I've got x squared plus xy plus y squared all over that x plus y. I've got that right now. All right, but something about this. I've got ones here, so the only thing I can multiply by 1 is 1 times 1. Everything's pluses. That means I'd have to add it and get 2 in the middle. So it's not going to, that top's not going to factor. So that's good. So then we've got a final answer there. So sometimes you might have a trinomial left over that doesn't factor, but most of the time they simplify a lot more than that one did. Okay, so this was a good review of that difference of two cubes because we hadn't factored that in a long time. Okay, so that was a good thing that that's in there. Okay, and we haven't done anything with a slide and divide, but slide and divide could show up in these as well. Okay, so let's do another subtraction one. That maybe we'll have some more factoring we haven't done for a while. So x squared plus 3x minus a 6. And then maybe all over an x squared minus a 5x minus a 4. Nope, let's make that a plus 4 because we definitely want all this stuff to factor. And then minus a 4x minus 4 minus 2x squared, x squared minus 5x plus 4. So we still got our common denominators. Okay, now again, this all goes together. This is a trinomial, no matter what order they write it in, it still all goes together because I'm followed by a subtraction sign. Now, technically, you could probably do the opposite sign when you pull it down in the next step, so then that way you're not writing 2 extra steps in there. Okay, so probably what I would do, especially after you get a little more comfortable with this, x squared plus 3x minus 6. Now, since I know it's a minus, and I've got to change all those signs, go ahead and change them in this step. So a minus 4x, a negative times a negative makes it a positive 4, and a negative times a negative makes it a positive 2x squared. All right, doing that in that step will at least save you one little step. Okay, go through and add some like terms. Okay, so I've got a couple x squareds in there. So 3x squared, put the x's together. Don't drop that negative right there. So minus x. And then negative 6 and 4. Again, don't drop that negative that's in front of that 6. So a minus 2. And then all over an x squared minus the 5x plus 4. All right, notice I keep scooting over to the left. I'm doing that on purpose because I know where I was going with this. All right, now on this trinomial on top, that is a slide and divide. So, I mean, you can slide and divide it all in your work here, but it might be easier to take this and do that slide and divide out somewhere else. Margin of your paper. They really did invent the margin of your paper for math people to do math. Okay, so then it just will clean it up a little bit. So I'm going to slide. So I'm going to take that down there. I'll have an x squared minus an x minus a 6. And then I've got that leading coefficient of 1, which is what I want. X and x. 3 times 2. 3 times 2 will get me a negative 1 in the middle. Unlike signs on the negative 6. And then don't forget the divide, because I always want to forget by the divide part. So once I slide, then I have to divide. That makes this one a 3x plus a 2. That makes this one an x minus a 1. All right, so again, when you have complicated numerators or denominators that need to be factored, sometimes just doing it in the side of your paper will save you a whole lot of headaches here. I am going to go ahead and go across. So I'm going to have a 3x plus a 2 and the x minus 1, assuming I haven't made a mistake yet. And then now this has a leading coefficient of 1. So I can guess and check this one. I can do an x, I can do an x. I can do, it's got to be a 4 and a 1. Minus, minus. Yep, minus, minus, because it's the only way I'm going to get the minus 5 in the middle. All right, and this one, finally, one that showed up on an angle. All right, x minus 1, x minus 1. Not that it has to be on an angle, it does not have to be. Okay, so then we've got a 3x plus a 2, and then we got an x minus a 4. Okay, so any type of factoring issue that we have had before, any type of, factor by grouping, perfect cubes. Oh, we didn't do rational root theorem, did we? We didn't factor that way. That's my pre-calc classes. So probably difference of 2 cubes or sum of 2 cubes, difference of 2 squares, slide and divide, regular x in front, or factor by grouping. And really on these, I don't see a lot of factor by grouping because usually they don't ever put 4 terms up there. So they're always usually trinomials. All right, so let's do, I'm either going really, really fast or this is just really easy or there's not very much to cover in this section. Yeah, not that I'm trying to drag my feet or anything, but we may get out early tonight. Okay, so let's go ahead and let you do one on your own. So let's do like an x squared over an x squared minus 9 minus 6x minus 9 all over an x squared minus 9. Okay, again, this one hopefully was pretty kind of easy because nice little trinomial. You can see right off the bat, you're going to have that trinomial in the top. All right, and again, if you think of, oh, hey, this is a binomial, that means I got to go through and change all my signs. You can do it all in the same step here. The x squared stays, all right, but the opposite sign here would be a minus 6x. And then this negative times this negative would make that a positive 9. Okay, so I really think that is okay to do that all that in the same step. Okay, all right, and then we've got the leading coefficient there of 1 in the top, so that's going to factor nice into a guess and check. So hopefully you had an x and an x there, and then it's got to be a 3 and a 3, so a 3 and a 3, and to get a negative 6, I'm going to have a minus and a minus. That gives me a positive 9, so yep, that's good. The bottom is the difference of two squares, so x plus 3, x minus 3. Okay, so yeah, see, this one was kind of easy. When they already have common denominators, they really are kind of easy. Those are the ones that everybody likes, can do quickly, and doesn't do too bad. Okay.